Okay, now in today's class we are going to study about clean room testing. Okay, clean room testing is also a part of our software engineering, in which we are going to have some special circumstances or special criteria which is going to be used. Okay, and so this clean room testing was pioneered by IBM. That was started by IBM. So what is this clean room testing? We will first of all see about the description of what are the main basic things of clean room testing. Then we will have about the characteristics of clean room testing. In next class, we will have the objectives of clean room testing and advantages and disadvantages. That's all. These are the things which are included in this clean room testing whole chapter. Okay. So, this is a very important chapter also, but a very small chapter in your software engineering course. So, this is mainly, it was started by IBM, as I have already told you. Now, it relies heavily on walkthrough, what we have studied in our previous classes. That was our code inspection, code walkthrough. Okay, you can see the previous videos for these things. Now, this heavily really relies on this code walkthrough, code inspection, okay, and formal verification. We have already studied about verification and validation also. So basically, this clean room testing, this mainly relies on these three things. That is code walkthrough, code inspection, and your formal verification, normal verification. Okay, so clean room testing is mainly having these things. Now, what is the next thing? That is about its name. Why it's called clean room testing? So this clean room testing name had derived from the analogy with semiconductor fabrication units. It gets this name, that is, name was derived from the analogy with semiconductor fabrication units. From this, we have got the name of our clean room testing. Right? Now, what happens in this clean room testing? That is, in this units, that is our clean room, whatever we say, defects are avoided by manufacturing in ultra clean atmosphere. We are talking about a clean room atmosphere, that is an ultra clean atmosphere where your software is being whatever verification or what these things are being done, this is done in an ultra clean atmosphere, so that the defects, okay, those defects which are coming to our software due to any kind of unneatness, that is, if your atmosphere is not clean, if any kind of defects are coming due to that unclean atmosphere, those things will be removed in this clean room testing. Okay, that is, in this units, that is clean room, in this clean room, defects are avoided. Some units are made which are called clean room. Okay, basically our software has been developed in such an environment where this clean room, units means, clean room means we are talking about some units where our software is being developed. So in these units, that is our clean room, defects are avoided by manufacturing in ultra clean atmosphere. We are manufacturing our we have been manufacturing our software in a ultra clean atmosphere. Due to unneatness, if any certain faults are coming, those faults will be removed or those faults can be avoided. To avoid those kinds of fault, we are using this clean room approach. Okay, basically it is for your neatness of the software. If some if your environment is not neat, that is, some hazards can come due to dust or due to any other thing. So in an ultra clean atmosphere, when your software is being developed, so these kinds of fault or your software manufactured, then this kind of fault can be avoided. Basically, this is the reason why we are using this clean room testing. So this is the clean room testing. So in this, what happens in these units, that is, we are calling the clean room as our units where we are manufacturing our software. Defects are avoided by manufacturing an ultra clean atmosphere. Your atmosphere will be an ultra clean atmosphere of the clean room. Okay, that is your unit where you are manufacturing your particular software. This is the thing which is done in your clean room testing. Now, in this kind of development, inspections to check the consistency, that is, when we are checking about the consistency of our software, in this kind of testing, what is happening, this kind of development inspection to check the consistency of the components of the specification had replaced unit testing. This kind of thing, what happens, we are doing the unit testing. In case of clean room testing, what we are doing, these certain components which are the components of our software which we are breaking, and we are going for the unit testing. So this unit testing is being replaced by this kind of testing when we are going for our clean room testing. Why? Because each and everything, when you are developing the basic software, or so these specifications when you are developing in an ultra clean atmosphere, so basic defects are being avoided. So this is being replaced by the unit testing phase. Okay, because here also we are working on the different units. That is our, here we can see the units, that is our clean room, where we are avoiding the basic defects due to whenever our atmosphere is not clean. So neat and clean atmosphere is needed, so it can obviously replace our unit testing. So here what is happening in this kind of development, inspections to check the basic consistency of the components, that is whether my components are working correctly or not. So consistency of my components are being checked here. So obviously when I am breaking my software into different components, this is what is happening in our unit testing, right? In unit testing, what we are doing, we are breaking the whole software into some basic units, and we are going to check these units one by one. So again here same thing is being done, because same thing, consistency of the components with their specifications, these are done, has been replaced by this unit testing. So here same thing is being done, right? Now this technique reportedly produces documentation. Obviously every phase we are getting a documentation. Obviously this phase will also give you some documentation and code that is more reliable and maintainable than other development methods heavily on code execution based testing. This will basically give you again some documentation and some codes which are more reliable than when you are getting some codes after your execution testing, that is code execution testing. When you are executing your code and then you are testing your code, at that time whatever code you are, after that whatever code you are getting, this code after this your clean room approach, when you are getting the code, that will be more reliable, correct? So this approach when you are taking, or this approach when you are using for your testing, whatever code you are getting or whatever documentation you are getting, that will be more reliable than those when you are just executing your code and testing that one. After that whatever code you are getting, this code will be more reliable. Done? So again let's see, this technique reportedly produces documentation. Obviously documentation you will get some documentation after every phase, we are getting that one, and code that is more reliable and maintainable. Since you are doing this thing in a clean, ultra clean atmosphere or a clean atmosphere, so obviously it is very easy to maintain also. So your code will be more, you can just maintain it more nicely than other codes. So it is more reliable as well as maintainable also. Then so that other development methods heavily on, which is basically relies on code execution based testing. That is, you are executing the code and you are just testing. Since you are doing it in a clean environment, sometimes what happens when we are not going for a clean environment, some defects comes when you are not working in a neat and clean environment. So since you are working in a neat and clean environment, your units are being worked or it's been manufactured in an ultra clean atmosphere, so obviously those kinds of defects will not come here, right? Now what are the characteristics of your, this is what is there in your clean room testing. Then now this is the basic description. What is the characteristics of our clean room testing? Okay, so first characteristic is formal specification. Now what is that? Software to be developed is formally specified. That is, formally you have the specifications of what are your going to be in your software. So the software to be developed, that is you are going to develop, is formally specified in this clean room testing. A state transition model, this shows system responses to stimuli is used to express the specification. So a state transition model is being used, okay, which shows you system which is reacting on the stimuli, that is which is responding on the stimuli, that is responses to the stimuli is used for this specification, for the purpose of formal specification in this kind of testing. Okay, so what is that? Software to be developed is formally specified, okay, and a state transition model is used here, so that from one state to another state, the transition which is going on, this model is shown here in this case. Why? So that the system responses to stimuli, how the system is being responding, okay, that thing is being shown for your specification purpose, formal specification purpose. So basic thing is here what the state transition model is used, the transition of the states, transition from one state to another state. This model we have already seen that thing also. So this state transition model is used here for formal specification. This is the first characteristic of your clean room testing. Okay, the second one is incremental development. Incremental development we have seen in our incremental model also. What was happening there? That is, we are going on from one phase to another phase, some increment is going on. Again it is going for some testing, again it is coming, then some increment is being done in your particular software, again we are testing that one, going for the testing, again customer feedback is good. So this was what happening in our incremental model. So here what is happening, software partitioned into increments which are developed and validated. Here the main thing is what? Validation and verification we have already studied. So here in every stage, first of all, your software is being divided or partitioned into increments, small units, okay, which are developed and validated separately. Every particular unit. Why I was telling you that you can it can be replaced by unit testing, can be replaced by this one, since here also we are breaking the whole system, partitioning the whole system, okay, into small units. Then what is happening, each and every unit is being separately validated, okay, they are tested and validated. Here what is happening, so developed and validated separately using the clean room process. Every single, whatever your software, suppose your software is this one, okay, so what we are doing, we are just breaking this into different increments, okay, or units. Now these units, these are developed in clean room process. Each and every unit is being developed in the clean room process, that is your ultra clean environment. What will happen for that one? Some faults or defects which are coming to your software, if your particular software is not developed in a clean environment, okay, unclean environment, if your software is developed, then some faults will obviously come to your software. So if your software is being developed in an ultra clean atmosphere, so this kind of defects will not come. So here your particular software is divided into some increments, and these particular increments are first of all developed and then validated separately using this clean room approach. Then, and what is happening, increments are specified with customer input at early stage in process. When the increment is going to be in the early stage of development or process, at that time some customer inputs, how, when these increments are specified, why specification, we are going for some validation. Who will give this validation? Some customer inputs have been taken, and this is the process how we are checking every increment. So when some increments are we are developing, then we are checking it with some customer inputs, and obviously some validation is given that yes, this is a valid one. So this kind of checking is done at an early stage of the process. When you are developing and at early stage of process, this is the checking is done for each and every unit or each and every increment separately. They are developed separately, they have been tested separately, and they have been given a validation for in a separate manner. So this is what is done in our particular clean room approach, and obviously this whole thing is done in a neat and clean environment. So this is the second characteristic, that is our incremental development is done here. Incremental model we have seen, there also we have seen breaking of our system into different units and working on the each and every unit separately. This is done here also, right? Now third one is structured program. What is structured program? Only a limited number of control and data abstraction constructs are used. Limited number of controls and data abstraction, that is number of control, limited and data abstraction constructs are being used here. Okay, so that if you are using some limited number of data constructs and as well as your controls, so obviously you will have some less number of faults. So limited number of things are used here in your clean room approach. And the program development process is process of stepwise refinement of the specification. Stepwise refinement is done here in our clean room approach. Okay, whenever as we are using some limited number of things, obviously stepwise refinement of each and every process is done here, and it will give you a defect free software. Naturally, since everything is done in a stepwise process, so obviously to find the defects or to find the faults and to work on them so that we can correct them on time as well as in a stepwise manner, it will give you a neat and clean software. Okay, a error free software. Now fourth one is static verification. Now what is a static verification? The developed software is statically verified using rigorous software inspections. Rigorous software inspections are done on this particular software. That is, the software is statistically verified. They have been verified. How? Rigorous, that is, software inspections are done on the particular software. Why this rigorous thing is done? So that each and every defect which is coming step by step, as I have already told you once, that whenever you are working on a software or working on a simple program, suppose you are having a simple program, if you are having some kind of error and you are correcting that error, maybe in some process if you are correcting the error, you are getting your result correctly. But in some programs, when your program is large, then what happens? If you are correcting one error, then again some other error is coming to you. Okay, so you are just going on getting the errors one by one. When you are just checking, testing, and you are correcting those errors, again some errors can come to you. So rigorous testing is needed so that each and every error is corrected whenever you are encountering that error, right? That is why here rigorous software inspection is being done. Now there is no unit or module testing process for code components. Here no unit or module testing, that is, I have already told you, unit testing has been replaced by this. So no unit or module testing process for code components are being used here. Since each and every module, each and every increment we are testing, we are doing rigorous software inspections, we are going for validation of each and every module or each and every increment. So obviously this unit testing or module testing is not needed for our code components. It is easily done here when we are going for a step-by-step refinement. Then this is what is there in static verification. So validation is there, verification is there. It is the full package now. Now last one is statistical testing of the system. Everything is done now. We have verified, we have validated, first of all developed, then verified, validated, everything is done. Now it is for the testing. What is done there? The integrated software increment is tested statistically to determine its reliability. These tests are based on the operational profile which is developed in parallel with the system specification. Operational profile, how your particular software will operate, how your particular software will work. So this is what is your operational profile of your software. So when we are going for this particular development whole process, with parallel to this, some operational profile of your software is also maintained or it is also done, okay, in parallel to your development process. So what is happening here? Statistically to determine its reliability, these tests are based on the operational profile which is developed in parallel with the system specification. So obviously tests are being done basically which is based on the operational profile. With your development of the software, some operational profile of your software is also made. So with matching to or with reference to your operational profile, whatever tests are needed for your software, made software, those tests are being done so that your system is fully operational and fully perfectly operational. Okay, so these are the basic characteristics what are done what are of your clean room testing. So after seeing these all things, you can easily understood that this clean room testing is been your unit testing is been replaced by this clean room testing. Here what is the main benefit, that each and every module is being developed in an ultra clean atmosphere. So due to neat and clean atmosphere, the defects due to unclean atmosphere, whatever defects can come, that will not come to your particular software. Again, each and every specification, each and every increment or each and every unit is mainly, they are developed separately, they are validated after testing separately, they are being validated, they are being verified. Here also we have seen structured programming, that is refinement is done step by step. Again, these things are being statistically verified due to rigorous software inspections are done here. So due to this whole thing, you can see the particular definition what we have studied, that is formal verification, walkthrough inspection. These all things have been done in our software. So we are getting a software which is up to a particular mark which is needed, that is which is matched to our operational profile. Okay, because in parallelly our operational profile is also maintained. And when you are testing each and everything which is needed in your operational profile, that whether my software is operating correctly or not, each and every test which is needed, that is also done here parallelly. So this is a perfect package for your error-free software, to give you error-free software, right? So these are the thing what is there in your clean room testing, that is characteristics. Next class we will see that what are the objectives of your clean room testing and what are the advantages and obviously some disadvantages of your clean room testing. If you have any kind of queries related to this today's class, you can ask me in your comment section. Any suggestions you can give that also. And if you like my channel, then please give a like and subscribe my channel so that you can get more videos related to software engineering and other technical topics. Till then, take care and have a good day.